There we go. And, okay. The technical content stops now. Yeah, this is a very different talk. I think it's time to start philosophizing a little bit. How many of you have played the game of Go? Oh, good, lots. All right. So people who learn to play Go, in fact, in the time I have to give this talk, I could teach the rest of you how to play. Not play well, but play, because it's a very simple game. And the name for the language is obviously the same as the game, and that's not entirely a coincidence, although there's more to the story. But the thing about learning the game of Go is that it's very easy to learn and really, really hard to master, because it's not like most Western games like chess. They're not analyzed by, you don't learn to say, well, if the person goes there, then I go here, and then they go there, and I go here. And it's not like that. There's 19 squared positions on the board, and the exponential is just crazy. Instead, you have to think about patterns and territory, and it's a very different and much more sort of holistic thing to think in. And it's very hard to teach us left-brain Westerners how to play Go. I've known some good ones, but I'm not among them. But there's a principle for teaching. It's really used for pedagogy, and it's the idea of a Go proverb. And there's a lovely little book that was translated about 50 years ago from Japanese into English called Go Proverbs Illustrated. And just to give you an idea of the flavor of them, here's one. The comb formation is alive. And that means that those white stones, if you attack, you can actually keep them alive no matter what black does, because you can always create two eyes. Don't worry whether you understand that or not. It's just, that's a nice little thing. The comb formation is alive. Or the carpenter square becomes ko. That's a really nice little proverb, because the black stones in this case, if you attack them white and play perfectly, you end up with a pattern called ko, which is a very strange, that's sort of the one weird thing in the game that you have to understand beyond the trivial stuff. But you see these have a kind of poetic, sort of nice feel to them, but they carry a lot of information for people learning how to play. When you see this thing on the board, you know, oh, I know what happens if I have this position, because I can create a ko, and that may or may not be a good thing. So I was wondering, can you have Go language proverbs? Can we think about teaching Go, or maybe understanding or explaining Go with a similar kind of Eastern philosophy approach? And I realize this is very, very wet stuff, but bear with me, because in fact there is already one proverb you all know. Don't communicate by sharing memory, share memory by communicating. I hope I got that the right way around. I usually do. And if you think about it, this is a proverb, right? It's a little tiny pithy statement, slightly poetic. It's got a sort of repetition in a way. But really understanding what that says is a fairly big deal, because you have to understand, what do you mean by sharing memory by communicating? Well, you mean passing on a channel the address of a data structure or an object, and also the idea that when you send that object over a channel, if you don't keep the pointer, then you don't have access to it anymore. And so safe, concurrent, or even parallel calculations sort of are inherent in this very model. And so there's actually a lot behind there. It's a nice, rich little thing. And I was thinking, well, maybe there's more of them. So I tried to come up with a few of them, and I'll go through my list, and maybe there's more you guys can think of. So here's another one. Concurrency is not parallelism. I think most of you know, if you've seen the talk I gave at WASA, Blake actually was the one who invited me to give that talk, that concurrency and parallelism are often confused by beginners. They think they're the same thing, but at least the way that you talk about them in the Go community, they're very different and important to keep separate. Concurrency is a way of structuring your program to make it easier to understand and scalable, and parallelism is simply the execution of multiple Go routines in parallel. It's somewhat less interesting a concept than concurrency. But there's a lot in those four words, right? There's actually a lot to understand. Here's another one. Channels orchestrate, mutexes serialize. A lot of beginners struggle with the idea of, when do I use a mutex or a sync cond or an atomic value, or when do I use a channel and a Go routine, and all this stuff. And one way to think about that is that mutexes are fine-grained and very small, and they tend to serialize execution. If you put a mutex on a variable, then only one thing can ever happen at a time to that variable. But and that's often very important, and sometimes that's exactly what you want. But in the big picture of the whole program, what's going on, Go routines and channels give you a way to sort of structure the program I'm using the word orchestrate here, to arrange how the pieces work and to generate the sort of large-scale service or whatever it is you're building. The sort of select for loop that everybody knows, using channels to orchestrate your program, is sort of the canonical example. The bigger the interface, the weaker the abstraction. Now, if you come from Java, where everything is bigger, you think of interfaces typically as having lots of methods. And people talk about how unusual it is in Go to have interfaces that are not declared to be satisfied. They're satisfied implicitly. But that's actually not the most important thing about Go's interfaces. The really most important thing is the culture around them that's captured by this proverb, which is that the smaller the interface is, the more useful it is, right? If the IO.reader, IO.writer, and the empty interface are the three most important interfaces in the entire ecosystem. And they have an average of 2/3 of a method, right? So if you think about the way that a Java guy would build it, he'd have the interface like this, and it would only generalize a little bit, because there might be 2 implementations of it. How many implementations of IO.reader are there? I've written programs with 20 implementations of IO.reader inside. Right, and that's a really powerful structuring thing. So this is really a Go-specific idea here, that we want to make little interfaces so that we can build components that share them. Make the zero value useful. This came up earlier today. I think this is something that early Go programmers don't appreciate, that you really want to try to arrange that the API to your package have the zero value of all the types inside it be useful right out of the box. And some examples in the standard library that show how important that is are things like the bytes buffer or sync mutex, where you just can put one of those things inside your structure, not even allocate it, or declare a variable of that type, and just use it. You don't have to call an init function, you don't have to think about it. And it matters even more when you're building complex data structures that have these things inside them, because the bytes buffer is valid as zero value is a valid buffer ready to use. If you put that inside another structure and you make all the pieces, other parts of it also valid zero, bytes.buffer doesn't break that. And so it's a way to structure your whole data to make sure that the programs are much easier to use. Now, of course, there's nothing wrong with calling a constructor. It's a perfectly good thing to do. It's often necessary. But when you can avoid it and make the program nicer, it just means there's less API there. And that's always a good thing, unless you're a Java programmer. This is one that may be a little contentious, but the empty interface says nothing. It actually carries no information. Just yesterday or the day before, I saw something with a bug where they'd written a piece of code and the function argument was an empty interface. And so they called it and it just worked, and they refactored some code and the program broke mysteriously because it couldn't be statically checked, because the function with the empty interface argument didn't force any guarantees on the caller. You might as well program in Python if you're doing that. So the empty interface is also something you see in almost every question on Stack Overflow about Go. There's always an empty interface. I'm doing this, and it might be like a map of string to empty interface, which is the least useful data structure there is. Because it's a map of names to meaningless objects, right? So when you're programming and you have an empty interface, think very hard about whether that's really what you want, or whether there isn't just a little something you could put into an interface with an actual method that really is necessary to capture the thing you're really talking about. Sometimes you absolutely need it. There's no question about it. But it's way overused, especially by beginners. Gofmt is, of course, a big deal in the Go community. And a lot of people say, I want Go, especially beginners, I want to move the braces, or why is there, why tabs instead of space or whatever. Who cares? Shut up. Gofmt's style... Gofmt's style is nobody's favorite. The way that it formats isn't even the way Robert Griesemer likes code to look. And he wrote the program, because we argue about it, right? But the thing is that if you ask experienced Go programmers their favorite thing about Go, a significant fraction, maybe even majority, will say their favorite feature is Gofmt. Yeah, I don't like how it formats, but I really like that it formats. So this is another one. A little copying is better than a little dependency. So this is when I first went to Google, one of the first things that was told to me that scared me was somebody who said, we really care most importantly about code reuse. And I thought that was a weird thing to say. And then I found what they meant was, if you could avoid writing one line by doing a number include, you should do that. And I learned that that was a very, very bad idea. And Google internally is still suffering from that decision. But You can actually make your programs compile faster, be easier to maintain, and simpler if you keep the dependency tree really, really small. And one of the ways you can do that is sometimes say, you know what, I don't need that whole library. All I need is these 3 lines of code that I can just copy and it's fine. And there's even examples of that in the standard library. Like strconf has an isPrint function to make it so you can tell whether a thing is printable or needs to be escaped under certain conditions. And one way to get that is to import the Unicode package and say, is it, does this match the isPrint category? But that involves something like 150 kilobytes of data. That's a huge dependency for such a trivial question. And so strconf actually has its own implementation of isPrint, which is tiny. It's about 5 lines of code, 10 lines of code. And that saves all that dependency overhead. But then, of course, there's a test so that every time strconf is tested, it guarantees that the Unicode and strconf packages agree on that definition. The test has a Unicode dependency, but the package doesn't. And that's a really good example of making code more compact and less dependent on other pieces. Don't be afraid to copy when it makes sense. This happened today, actually. I wrote this a while ago, but somebody was complaining that the Syscall needed to be changed because of a problem. It wasn't portable between 2 different versions or 2 architectures. And Syscall isn't portable. That's the point. It's a system-specific package. And if you import Syscall into your file, your package, you must have a build tag for the particular architecture and operating system that Syscall invocation is valid for. If you think you have a portable thing, you're using the wrong package, you should be using OS or something else. You should always guard your Syscall uses with build tags. So Syscall must always be guarded with build tags. Not very poetic, but it works. Here's another one. CGO must always be guarded with build tags for exactly the same reason. If you're calling C, God knows what it does, right? Under the covers, it's very, very non-portable. I mean, I know we think of C as a portable language in the old world, but it's really not. And the open source community has made sure that it's become less portable over time. And so if you use CGO, you should have a build tag to make sure that the CGO you're calling in is protected and will only be invoked on the guide. It may be that somebody grabs your package and builds it, and it fails to build because the build tags don't work. That may be a good thing, because they may have had a binary that built but didn't run because a CGO dependency isn't actually useful on that computer. Or even worse, doesn't work very well and breaks. Here's another one. CGO is not Go. A lot of people early in the early days of CGO appearing would write blog posts about one of their favorite features of Go was how easy it was to connect to C. And I think that's a trap, because sometimes you have to. There's no question. There's definitely fantastic, efficient, or expansive packages out there that really deserve to be used rather than rewritten. But I'll confess, I've actually never used CGO. I've never wanted to. I've certainly used programs that have it, but I've never actually written a CGO invocation myself except in tests, because I think we have a universe where we understand the memory, we have safety, we have correctness, we have stability, we have garbage collection. You put CGO in, all those things go out the window. 90% of the time inside Google, when someone says, my program crashes, please help me, my runtime corrupted, it turns out it's a CGO or a SWIG problem and not the Go code that's causing the problem. That didn't work. With the unsafe package, there are no guarantees. If your code, the other 10% have unsafe. It just says it. A lot of people use unsafe and then complain when their code isn't portable or changes after a release or something. In fact, there's one guarantee, because we're too afraid to break it, but I'd like to break it. People use the unsafe package to get at things like string headers and slice headers, which means it's very difficult to consider changing the layout of string headers and slice headers, even though we'd like to. And maybe one day we will, but then we'll break all those programs that use unsafe to get at them. And tough to them. Don't use unsafe unless you're prepared to have your program break one day. Clear is better than clever. Now, so far all the proverbs I've shown you have been sort of general, mostly general sort of programming things about Go. You might say that this one is actually about programming in general. You should always be clear, not clever. But there are languages where cleverness is considered a virtue. The more compact the code is, the tighter it is, the more it uses built-in facilities, the better. Go doesn't work that way. We don't like to, especially when you're learning Go out of the box, you should be thinking about writing simple, clear code rather than trying to make the cleverest, densest stuff you can. And that has a lot to do with maintainability, stability, the ability for other people to read your code, things like that. So it's a philosophical point, but it really is part of the Go philosophy. Reflection is never clear. Another thing you see on Stack Overflow a lot is people trying to use reflect and wondering why it doesn't work. It doesn't work because it's not for you, right? Very, very few people should be playing with reflection. It's a very powerful but very difficult to use feature. It has only runtime checks. At compile time, there's very little checking going on, and the code is utterly impenetrable. I've probably written as much reflection code as almost anyone in Go, and I still hate it. And I think we should encourage beginners to step away from using the empty interface and step away from using reflection and use the language proper, because they don't need to use these things nearly as much as they think they do. Errors are values. This is another one. Again, beginners struggle with why do I have to have if error not equal nil all the time? Well, it's because you're not programming. You're just writing code. They're not the same thing. You may know I wrote a blog post about a year ago where I showed a programmer in Japan who was really complaining about this, that he just wasn't writing programs. He wasn't thinking about errors as values and programming them to good effect, so he could write, essentially abstract the error handling away and make his program really pretty and clear and easy to understand. And too often people just write if error not equal nil, and I think beginners to Go who maybe have been influenced by thinking of errors as an exception or some other control structure like try catch, they think of that you just substitute try catch for if error not equal nil. But you can't really program with try catch because it's a control structure. It doesn't work. But errors are just values. You can write code. You can put them in for loops. You can store them in variables. You can cache them. You can put them in a map. You can send one to your mother. Whatever you want. They're just values, right? And then, if unrelated to that, but just as important, don't check errors. Handle them gracefully. Don't just write if error equals nil, return thing. Think about whether you should be doing something with that error, decorating with more information, or should you remember it for later and print it when you've done some other things. A big part of all programming for real is how you handle errors. And people are too quick to jump to just return error up the tree and forget about it, rather than thinking about how an error should really work. And a really important part of writing good Go code is getting the error handling right up front, of any program, really. But because errors are just values in Go, it's easier to program and therefore easier to do it gracefully. This one may be just totally bullshit, but I tried to find proverbs around these, and I ended up writing one to cover all of them. Design the architecture, name the components, document the details. What this means is when you're writing a big system in Go, you design it as a sort of structural thing. Think about the components are, what pieces work in parallel, and then think of really good names for the pieces, because those names are going to be what appears on the page in the Go program. And if the names are good, the components will be easy to understand, and the design will be clear inside the structure of your program. If you give good names to things, the programming feels very natural. But there's a lot of stuff that you have to explain, and so those are the details you explain. But the name should carry a fair bit of the weight of expressing the design that you've architected, and the details are just what goes in to fill in the gaps for the stuff that's maybe the fine print on the engineering diagram. Documentation is for users. Now, a lot of times people write documentation, they say this is what this function does, and they don't think about what the function actually is for. And there's a really important distinction. This function returns this, right? Why does it return that? What should it return instead? When do you use it? Think about the documentation you write for your GoDoc presentation. Think of yourself as the user of that package rather than the writer of it, so that the presentation that GoDoc gives is something that the user will find helpful. It's true for any programming language that the documentation is really about what users see. But because of the automated presentation in Go, like many other languages nowadays, but also because the documentation is so lightweight. It's not annotated. There's no HTML or anything. You can just write prose. So think of the user when you write the documentation. Don't be afraid to explain things so that it makes sense. So that's my list. There's probably a lot more. I winnowed it down a lot to the ones that I thought would be easy and pithy. I don't think of these as things that you guys need to know. I think you know them already. But think about them as ideas that you might use to explain to somebody why something, maybe in a code review, or when you're teaching someone new about something, or trying to stop an argument on Stack Overflow or whatever. And I'd like to think there's lots more, and maybe you guys have more you can think of, and if you want to mail them to me, and maybe we'll collate and have a bigger list. Maybe this will turn into something that the community maintains on the wiki, or maybe when you leave tonight, this will be the end of the idea. I don't know. It's an exploration. But if you think about the Proverbs, back to the original idea of Go Proverbs from the game, they have to satisfy several criteria to be the idea of a proverb. They have to be really short. They have to be kind of poetic. Not all of the ones I wrote today are particularly poetic, but some of them are nice. Because you want them to think of it sort of like it's a little saying, right? It's something that will be memorable. You also want it to be general. Now, some of them are specific about a particular thing, but they're the kind of things that almost every program should have an example in somewhere of what that proverb represents. It's not like, if your function has 3 arguments, it should probably only have 2. That's very, very specific. You want something more general and sort of more, silly in a way. And it's possible they probably should be more about Go than about programming, because there's a lot of opinions about how to program. But one of the things that Go has done, I think, is create a community around a certain way of programming. And the idea of these proverbs is to try to capture some of those ideas that make programming in Go different and maybe better. I don't know. But also they might be contradictory. Proverbs aren't always, I think real proverbs in the real world, you can find lots that are exactly the opposite. And that's okay too, because sometimes one engineering decision is right, sometimes the exact opposite is the right thing. But that's okay. So if you think of more, or you have ideas, or you want me to stop talking about it, let me know. And that's it. Thank you.